Okay, so today we're going to learn about the inverse of functions and their graphs. The definition of inverse. Let f and g be the two functions such as that for every x in the domain of g, and then I have it wrote out here, and then for every x in the domain of f. The function g is the inverse of the function f and is denoted as the inverse, which reads f inverse. Thus, f is the inverse of x equals x, and the inverse of f of x equals x. The domain of f is equal to the range of the inverse and vice versa. An example, the inverse of a function that has all the same points as the original function except the x's and the y's have been reversed. For instance, suppose your function is made up of these points. Okay, so we have 1 and 0, negative 3 and 5, 0 and 4. The inverse is given by the set of points of 0 and 1, 5, negative 3, 4 and 0. Note that the order of the points does not matter. You can rearrange the points so that x's are in order or not. It's your choice. Graphs of f and the inverse of f. F must be a one-to-one function. The inverse is a reflection in the line y equals x. For instance, point A and B on the graph of f is reflected off the line y equals x and becomes point BA on the graph of the inverse of f. And here's an example. It's an illustration of a graph of a one-to-one function and its inverse. That kind of gives you an idea of how it would look. I hope this video helped.